Hello, and welcome to today's webinar. My name is Adam Golov, Marketing and Communications Manager at Data Conversion Laboratory, and I will be your moderator today. Before we get started, I want to let you know we will allow time at the end of the webinar for questions and answers, so please write your questions in the chat area as they come to mind. If we don't have time to answer them all, we will make them available on our website. Next slide, please. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. Next slide, please. DCL services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Next slide, please. We serve a very broad client base. Next slide, please. Spanning all industries. Today, we are thrilled to introduce Nave Greenberg, Director of U.S. Defense Development for DCL. Nave is a PMI certified project management professional with expertise in large-scale complex conversions utilizing numerous DTD standards. He specializes in conversions for DCL's defense and TechDoc business units and has been instrumental in developing DCL's DITA 2361 40051, S1000D, and 38784 conversion software suites, as well as working with clients to develop detailed project business rules. Nave is a member of the United States S1000D Management and Implementation Group, Land Working Group, and participates in other discussion subgroups. He has been with DCL for over 10 years and holds a BE in Mechanical Engineering from Stony Brook University. Without further ado, welcome Nave.
Thank you, Adam. Hi, everyone. I hope everybody's doing well. Just as a start, initially this was supposed to be S1000D specific, but we opened it up to all other types of conversion. And the main reasons for that is that, first of all, not everybody has to go to S1000D, but mainly the process of developing your plan and analyzing your legacy data is very similar regardless to the standard that you're going to. And just to clarify, it's similar in most steps, but not in all steps, and we'll cover that. So the agenda for the next 45, 50 minutes, I'm going to try to cover some of the difficulties in converting your legacy data, then continue with how to plan properly for a successful conversion process and how to implement your plan. I will show some examples, and if you have questions at the end of the webinar, I will try to answer them. So in any type of conversion, whether it's S1000D, DITA, NLM, all the military standards or DoD standards, basically any type of conversion, you're still facing very similar issues. First questions that we always hear, and probably rightfully so, is how do you ensure that text is not dropped during conversion? So besides the obvious reason of missing data, the other reason why it's such a critical and important question is that it has a domino effect on your entire process. The saying garbage in, garbage out applies over here. And just a quick example is if you OCR your data and the text refers you to figure 10, and let's say I is mistaken with 1 and 0 is mistaken with 0, it will be a problem because you either, if you have an automated tool, it would not reference that. Another issue is tables. There's always issues that comes up with table. But if you have a solid process, table could be a very straightforward item to convert. In MathML, in some standards, you can use MathML to tag equation. And in standards like S1000D and other military standards, they don't really support MathML, so you need to determine what to do with the equation. And one option is to convert them to images, raster or vector, depending on your budget. Special characters or symbols are somewhat similar to math, but you also have that extra challenge of extracting those special characters during OCR or even converting them to the right entity. Determining correct hierarchy, that sounds simple, but it's not always an easy task. You have a lot of variation in how data is structured. Also, when converting to XML, and especially to S1000D, the concept of pages goes away. So what do you do with text that refers to pages? Like, let's say, go to the next page, or see figure on page 2-7, or the next few pages will cover repairing of the engine. We actually keep the page break until almost the end of the process, and we'll cover that when we talk about normalizing the data. And irrelevant cross-references. Again, if we're talking about standard like S1000D, 40051, 3001, you now need to worry about what is now a data module or a work package. You could have a case where the reference goes to a paragraph that now is actually a standalone data module, or an introductory paragraph to numerous data module. Reuse, identifying reuse content. Beside the famous saying, convert once and use many times, it can also be used as a QC tool. Writer creativity. This could really be a webinar just by itself, but most legacy data was written with no real standard in mind. And even if it was written to a specific standard, there was no real solid way to enforce it. Writers had really in their mind, how do I conserve paper? Because everything was print and everything was outputted on paper. So you end up with a lot of creative way to represent the same thing, like maybe procedures done as tables, or alerts they're done only once, but they actually refer to many sub-paragraphs. Like unusual text flow, to make use of the, most of the real estate on a page, you have text flowing in an odd way. And you can go on forever. And really the short answer on how to mitigate it is by normalizing the data. And I will eventually explain what normalizing the data means. And this actually perfectly leads to the biggest problem, which is really us. People are used to seeing a visual breakdown of the data. And for some, it's difficult to get used to the new document paradigm. And if you go to standard like S1000D, it's even worse. And people are so reluctant for this change, and not necessarily for the right reason. If in standard like S1000D and 40051, you actually categorize chunks of data according to the content and what they actually mean. And it takes a while for people to get used to that. It gets to that document paradigm, but but it's the same way it took people to get used to ebooks or other kind of technologies. And it's important to push these types of standards because it does make your data a lot more richer, searchable, and powerful. And the last point is that you also need to find a way to have all the stakeholders involved, and all of them have to agree on all the conversion rules. So how do you move forward and make sure that everyone is on the same page? So the answer is really easy. The answer is plan. And planning is probably the most important thing. And you obviously have to implement your plan correctly, but planning will save you a lot of headaches down the line when you get into conversion. So in the spirit of S1000D in reuse, this is a slide that I always use, but really because it's a really good slide. And the quote of President Lincoln that he said that if I had 8 hours to chop down a tree, I'll spend 6 sharpening my axe. And that should be your approach for conversion of legacy data. And and one way to mitigate the risk of poor planning is by asking the right questions. For example, who are the stakeholders? And really anyone that is involved in the project is a stakeholder. And it's the management, because you need to get the buy-in or maybe a budget or resources. It's the XML experts or the SME, technical SME. You need to use them wisely for SME-worthy tasks, because other tasks can be accomplished by others, and that could save you both time and money. And there are many other stakeholders, but a crucial stakeholder is the final client. And you don't want to find, you don't want to find out at the end of the process, and when you deliver the product, that the client is not happy. So you need to get them involved really throughout the process. Knowing the volume and the deadline will also allow you to plan accordingly and develop a reasonable schedule. Your process will be different depending on the volume, or let's say if you have 3 months versus a year to convert a project, but knowing that upfront will allow you to plan properly. Also, what standard you're going to. S1000D, DITA, NLM, DocBook, any kind of proprietary schemas. The process is somewhat similar, to all the standards, but once you get into the mapping of the data, that's when things kind of diverge and become different from standard to standard. It's also very important to know what content management system or rendering tools will be used. So in theory, when you go to any type of standard and you convert it, and according to the conversion rules, the content management system or the rendering tools should work properly, but that's not always the case. And what happened, a lot of people just jump into conversion, convert all the data, and then at the end find problems when trying to load the data to the content management system. So source format also affects your process. If your source data is paper, you will need to take into account OCR, cleanup, proofreading, and this usually translates to a lot more time, resource, and money. But it does allow you to manipulate and restructure and clean the data in a more familiar environment, whether it's your original source data or in Microsoft Word. So you can hire a lot more people at cheaper cost and a lot more resources to do the work. So source data in electronic format will save you time because you don't need to OCR and do as much proofreading and cleanup, and also actually in some cases you can use paragraph styles that are used in the source data. But what we found out is that styles are obviously not used consistently in the legacy data. And we'll cover that when we get into normalizing the data. Budget is always an issue. Obviously knowing your budget is very important, and in many cases the more that you have, the better off you are. There's obviously unknown, but knowing the process up front will allow you to estimate some accuracy every step of the process. And learn from others. So this is really easily said than done, but try to join many discussion groups. Other group members probably share the same or similar challenges that you have. One of the things that we keep hearing is that people don't like to share information. And in many cases that's true, but what I tell people is try to find presentation in a conference that talk about success stories or lesson learned. Usually conferences publish all the presentation a week or so after they're done. Or maybe just go and attend those conferences and try to get friendly with this, with these people. I don't know, buy them a drink, get them drunk, whatever, to get them, to open up and share some information. And you will be surprised because almost everybody loves to boast and talk about their success stories. Next, try to get as much of the source data as possible. You need that for analyzing and look at inconsistency and variation. And the more that you have, the more accurate your analysis will be, and less surprises you will have during conversion. Also, build a solid team. So you don't need to be an expert on the standards you're migrating to, but you should know enough to make logical decisions during the analysis and when developing the project-specific business rule. And finally, have a process that makes sense. And I will cover that in the next slide. One point actually before moving forward is that the easiest way to get the answers for these preliminary questions is by creating maybe a questionnaire that you can interview the client or interview the technical person or the authors or the writers and try to get as much information as possible. Questions like, what type of manuals do you have? What is the source data? It will allow you to know what you're starting with and what to expect. So like, do you need to add scanning, proofreading to the process? Will this affect your schedule? If you have troubleshooting flowchart or IPB tables that are not written very well up to the standard that you're going to, you may need to get a subject matter expert involved at the beginning of the process, or involve the client and set expectation. And if we talk specifically about S1000D, if you know you're only going to deal with procedural and descriptive data module, your process is a lot easier. And if you need to deal with process DM or applicability, you will need to know that at the beginning of the process and take that into account. So let's move on. And this is just an example of sort of a process that makes sense. And again, nothing is set in stone, but it's a very good model to follow. And we actually break the process to 5 sub-processes, 5 phases. In phase 1 is when we usually analyze the data that the client has. We also assign a project manager and start building the conversion team. In phase 2 is really where you create the conversion specification and hand tag sample. And the conversion specification is basically the tagging rules of the conversion process. And you should definitely walk through the conversion specification with the client or other stakeholders to make sure that everybody is on the same page and have a sign-off that everybody agrees that this is going to be your conversion rules. And obviously this is a live document that as you see more data, it's going to grow and add more rules, but you need to have some sort of a sign-off that people agree that they're on the same page. And based on the conversion specification, you can produce a tag sample to show that all the rules were implemented. It will be great if you can actually take that sample tag and produce maybe a sample item or upload it to the content management system or render it with the tools that you're using, obviously only if you have that luxury, but that, again, will save you a lot of time down the line. In phase 3 is when the conversion or the QC software is developed or customized. Phase 4 is where a proof of production should occur, and you should run a large sample that is representative of your entire data set throughout the process. And when everybody is happy with the results, you can move forward into phase 5, which is really the production phase. So again, in a typical project, you get the source data either in batches or even all at once, but regardless how you get the source data, there has to be a way to log the data into some sort of a production control system. So you can keep track of all the units. And the units can be a manual, a set of manuals, maybe predetermined batches or anything that has to do with a specific model, but really find a way to track a set of so-called units. And you can also record metadata on each unit, and that can help you create useful reports. And metadata can be a batch number or the number of pages or the date the unit received. And as you convert the units, you can track additional metadata, for example, of each date that each step occurred. And then you can actually have matrix on how long the process takes you. And if you see that one step takes a lot longer than what you think it should be, you can find out earlier in the process. And really that information is very useful to project delivery schedule, obviously confirm that the processes are working properly, and track each unit and see in what step of the production process that unit is in. So next you need to decide what data to convert and in what order. So first you can categorize the data, and some of the categories you can use are active documents that are in good shape, active documents that need a lot of work, or somewhat inactive documents that are likely to be retired, or archival material that you probably will never use. And then you can prioritize your data. So documents that are mostly used and documents that are customer favorite or documents that have the longest product life should be high on your priority list. And documents that are about to be retired or not used or not sustained at all can be low on your priority list. And once you create your priority list, start with the most recent and higher priority documents, and only then go back and depending on what the budget and how much time you have, start converting the lower priority documents. And at this point, you need to determine the conversion process that we discussed before. So if there are any documents that you can look at them and see which documents I can convert as is. It could be documents that are already in modular format or ones that are in really good shape. You would also need to do some preliminary work on the file. So maybe clean up and restructuring of the data or fishing out some of the metadata before you begin the conversion. Some data actually may not be ready, and then you may need to rewrite. And especially in cases when something is required by the standard and is missing in your legacy data. And specifically in S1000D, items like preliminary requirements, introductory data, or any kind of missing or structured in a way that requires you to manipulate the data before conversion, you need to kind of flag those cases before. And you also need to determine some data that maybe is not worth converting. And if you still want to have access to them from your converted data, you can just either link to them as an external file or maybe convert them to a section or data module, depending on what standard we're going to. So why reuse so important? And really, what does it have to do with QC or QA actually? The idea with content reuse is that every time something is used, you actually use it, you pull it out and convert it only once, ideally. And you can assume that front matter will be similar in many documents, but how similar you can't really tell just by looking at it. And it's impossible to tell where else in your documentation you can find duplicated data without an automated tool. But reuse is very important. And some of the benefit is that it increases consistency, it reduces development time, it lowers maintenance cost, it allows rapid configuration or usage in other publication, and by knowing your reuse potential, your process will improve, because now you can really go through a reuse report, find a set of documents that are in good shape and make that kind of your base document, and then take other documents again, those base documents, and adjust the similarity, the paragraphs that are similar or identical and so on. And by the time you're ready for full conversion, you have a real set of sections that are identical and can be pulled out. So this is just an example, a snapshot of a report that is produced, and the pie chart tells you a lot, and basically in this case said that you have 25% of your data is duplicated and potentially can be reused. And that can be an immediate saving of 25%. Now obviously this is not necessarily the case with every data, and that not every duplicated text will be converted once and used many times, but it's a great thing to have at the beginning of the process. I mean, you will need further analysis, but if there's a chance to cut costs by 10, 20%, simply by not converting your duplicated data, that's a lot of saving up front. And and you can also deal with paragraphs that are not identical. You have similar paragraphs, which I'm going to cover over here, that if you have similarity, you can use applicability or maybe fix your typo. So in the first example, you can see that there's an exact match of the base paragraph in 3 other manuals. So, specifically in S1000D, you can view that section, and if you have more identical paragraphs before and after that paragraph, like a sequence, you may have a case for creating one data module and reuse it 3 times. In the second example, and this is where we touch QA and applicability, there isn't an exact match, but it's close enough to raise a flag and indicate the possibility of reuse. So you can see that the first paragraph discusses part number or model number FD-5200. Well, the second paragraph is about FH5200. So here you can still reuse this paragraph, but possibly use applicability or effectivity, depending on the standard that you use, to distinguish between the part number. Another difference is that the first paragraph tells you that fill wells shall be visually inspected, but the second paragraph only tells you that it should be inspected. So the word visually is missing. So it could be a typo, and then you can fix it. And even if it's not, you can use that paragraph possibly by applicability. And so it's a great tool both for reuse purposes and QA purposes. And we find a lot, especially in legal documents or or documents that are somewhat repetitive, that there's a lot of typos and a lot of documents, the whole shall and should in the military used a lot. That tool can be used a lot to flag a lot of typos. So when we get into the step of extracting data, there's a lot of OCR tools that do a very good job, and they guarantee 98% and so on. But a lot of times, if the text is structured in a way that is not usual flow, you can get garbage out. And a lot of time, like for example, in the first example, you can see that this is just an item that can be done as an image or set of equation. If you don't want to deal with that, you can make that as an image as well. And the tools out there that actually will go through the document, determine the accuracy percentage of the data, and say, okay, this is very low. I'm going to make that item an image. And in your document, actually, the chunk of data that it extracts will put a placeholder and link, and then you can have by automation actually link into the image or the icon or whatever item that it is. And we actually doing that, and it produces a very, very high accuracy rate on converted data. Now, we obviously have some built-in tools in OCR tools that allow you to do a spell check or maybe go through the document and flag any kind of characters that the OCR tool determine in a low accuracy rate. And you can go and do one by one, but that's a very time-consuming task if you're dealing with a lot of pages. So one easy way to help you with reviewing the data and proofing the data is creating unique style that can, let's say, take the one and put like a strike through it, or the O put like in a way that it's easy to determine between an O and a zero. Spaces, a lot of times spaces are eliminated in proofreading, actually indicate a space. So by viewing the data, you can quickly, detect, flag the errors and look through the document and see any kind of typos. So you can create as many fonts as you want and actually flag those cases. And also change your process. When you go into those windows of the TIFF image and the outputted OCR data, if you have it open up front, it's almost impossible to track where you are in the document. Simply by minimizing the window of the TIFF image and the OCR output, and by pressing the arrow key every time, it will follow character by character, and you will have a much more accurate result, and you will miss less than what we do if you open just a brand new window. So moving on, conversion specification is a great QA document and a great method to have all the stakeholders on the same page. If you want to tie it to S1000D, to some extent it's your project-specific business rules. And in the conversion specification document, you can list elements that you find during analyzing your documents, examples of where in the document it was used, basically a concrete rule of how these elements are going to be identified. You can have some sort of an example of how it's going to be tagged, and any kind of open items. If there's any question, if something is not consistent, you can document it over there. And again, you will be surprised how effective just this document can be. By having a document that lists all the, most of the major rules in one centralized location, there's less of a chance to, for errors and disagreement. And and again, touching again S1000D, in S1000D you have your DMRL that takes care of your top level element of the data module, but it doesn't actually cover all the generic elements. So conversion specification in S1000D is an extension to the DMRL. And also creating a DMRL can be a challenge, and really the easiest way that we find to create your beginning of the DMRL is extracting all of the title into a spreadsheet. And that's not such a surprise, but one way to do, and again, but the problem is that one way to do it is by using the document table of contents. And the problem with people using the table of content is that it's not always the complete list. Some table of content only cover the first 2 or 3 level of hierarchy. And also in many documents, especially in old legacy data, you have a lot more levels and that they are not listed in your table of content. There's also the risk that when the document was updated, in the past, maybe the table of content was not updated as well. And, that can be in very old legacy data. So it's very, we found it very useful to prepare the data before creating the DMRL. And again, by normalizing the data, and I'll explain that. And also styling the title. And this applies to any kind of standard that modularize the data, like DTA, 40051, and so on. So again, I keep saying normalizing your data. So what exactly do I mean by normalizing your data? Your data comes in structured or styled differently from one step to another. Steps can be confused with lists. Tables are not structured properly. Even if the data comes in electronic format, styles are not used consistently. So you can try to convert the data as is, but there's going to be a lot of cleanup when the data is converted. So again, this is just an example of data coming in different ways and formats, and this is a good example of how to conserve in real estate. In the page real estate, you have attaching path for specific items. But when you convert the data, you actually have to associate that attaching path to all the other items. So what I'm suggesting is to try to clean up or prepare or normalize the data before you jump into full conversion. And and again, the reason for that is that you have a lot more people and probably at a cheaper cost that can normalize the data in a more familiar environment, like your existing source data format or Microsoft Word, than just having somebody in XML go back and try to clean it up after the fact. So you can create a styling document like this one, and where you normalize the data, and that way you can make it easier. And this is just an example of a document that styling were used in a very simple way, where you have heading and so on. And just quickly adding to the QC is simply by making the 1 and the 0 different colors, it's very easy to track any kind of typos. So you can see 1 and 0 and so on. So, and again, once you finalize the rules of QC, it's easier to automate and develop all kind of rules. So this is a very simple Visual Basic documents where we actually QC the text. We look for suspicious characters. We style, we make sure that the style is consistent. Any kind of creative tags that I'm going to cover later. Figure name, if you have a way to rename your figures and you can do it consistently, you can check if something was skipped. Check that the table headers are highlighted and something is tagged as a table header, not as a table body. So, for example, I don't know if it might be a little bit difficult to maintain, but checking the text, an easier way is to checking against a dictionary or so on. But in military documents, it's a problem because you do have a lot of odd kind of words that are out there. But for example, looking for a word that has digits inside, that could be a suspicious document. And you can actually go and check each case and make sure that it's okay. And you don't need to be an expert to do that. Here, for example, the software expects the next level, which in this case is the power 0, to be 1.7, and you have like a space over here and so on. And you can see that the numbering is done properly, because if you have the space over here, the conversion software may think that it's just 1 and not 1-7. And in this example, you have 2 items. You see over here, what happened a lot of time when you OCR data, there's hard return. So when you open the step over here, you have a hard return and it's mistaken it as a step 3, and that's not the case. This is actually a continuation of this paragraph. And all of this is done by automated way after you normalize the data, and it's very easy to check for errors. And again, another example of how it's very difficult to detect these errors during OCR where steps are combined. So it's very easy to write a tool that goes through your document and make sure that the numbering is proper. So you have 1, 2, and suddenly 4 done at the same step level. And you can have a way to do it. And there's, again, many ways to check your data and QC it. So again, in taking normalizing or pre-editing a step further, it can actually help you with more complex mapping. So here you have data that was normalized according to appearance, and if you convert your data to section or just even as nested topics, the conversion software will have a very easy task mapping the hierarchy to the appropriate element. But if you go to S1000D or other modular standards, normalizing the data is not a lot different from other standards, but you do have additional steps that you need to take in. So the metadata or the preliminary requirement here is styled the same way as other data, because you don't want to add like another layer of QC when somebody normalizes data. But because they were styled as header, it can be flagged in your DMRL, and when all the styles, the header styles are pulled out, like para0, sub51, and so on. And they're all extracted to a spreadsheet, and you can flag the tagging over there. And again, another option, if you want to rely on automation, is use keywords. So if you review and analyze the data and you see that every time you have an initial setup and material level and tools and special requirements, if that's the case, that can all be done by automation. And you just have somebody go through the document and just make sure that it's properly tagged or properly styled and done properly, and you can do rely a lot more on automation. And the important thing to note is that once you normalize your data, the converted XML files are a lot cleaner. And but for this example, let's say if you take S1000D, you don't want to break this into multiple data modules. All you have to do is really just either style this as a step and then continue as lower level hierarchy steps, and the removal and the return and place in the step, and then either mark them in the DMRL as procedural steps. But an easier way is just changing the style to step 1, and then you need to fix the step hierarchy below it. And when converting to XML, and especially S1000D, the concept of pages go away. So why do we still maintain the page number or the original labels and so on? And there's few reasons for that. I mean, first, it's a good practice for QA purposes. You can track the text all the way through the process. So people that review the process and review the data will have easier time knowing where the legacy data went to. And this is critical when going to complex standards when you move text around. But the second reason is we maintain that is because in your legacy data, you have references to pages. So if you maintain page breaks throughout your process, the software now really has a bookmark to go to. So what you can do by automation is actually link to the major element in that page. So for example, over here, and actually I'm going to go to the next slide, the other slide. Like over here, if it says see page 2-3, and you go to 2-3, the software can automatically link to the first sub-element regardless of what it is. The software knows whether it was done as a data module or as a procedure or whatever. But that can all be done by automation, and you don't need to QA that as much as you will done if somebody done it manually. Because if it's a clear set of rules, conversion software is flawless. So, the last item I'm going to cover is table processing. So tables can be a very easy item to handle, but at the same time, it's also a very easy thing to screw up. And here is just an example of all kind of variation of tables that, if a table comes in as an image or as a paper, you need to OCR it, you need to proofread it, but it's very easy to make it a table. If it comes electronically, a lot of time, they're separated by tabs, and sometimes the tabs are not accurate. Here you may have 2 or 3 tabs. So you can't just convert it or have a rule that every time you see a tab, make it a table. You do need to find a way to, again, normalize your data and put it in the table format, because tables are very easy for software to convert once they're in this structure. So this is a good example of a problematic table. First, it spans over a few pages. You also have this curly brackets that indicate jumpers, and the number of columns really change from page to page because of the jumpers. And you can have one table, multiple T groups, but when rendering the table, it's not going to look very nice. So one option is to convert these tables to images, but that's not ideal because the text is not searchable. Another option is actually to replace the curly brackets and merge the cell to indicate that those belong to this jumper. And again, the reason for the TS and ET, that's what we call created tag, is to tell the software, okay, you start the table over here, when you get over here, combine it to one big table. But you have to make sure that you have the same amount of columns in each section of the table. And the del row over here is just done if you want the software to remove those empty rows that are used really just to make sure that everything is has the same columns. And it's extremely easy to write a QC tool that actually goes through every section and make sure that you have the same amount of columns. The nice thing about it is that really the first section is the one that needs to look nice and have the same column width, because all the other section will inherit a lot of the attributes over here. And you can develop a rule that maybe even alignment can be done the same way, but obviously that's a case-by-case situation. So, another layer of QA can be added when viewing the conversion document. So even once you get into your converted data, we usually use a kind of a PC-based style sheet, and it's specifically designed for the projects or the standards that we're going to. And it highlights potentially problematic areas. So let's say list versus steps, hierarchy level, typos, references, table structures. All of them are being highlighted to enhance issues. So you maintain the original numbering, which again, as a last step, you strip it out because everything is auto-generated, but you can track the data, the source data versus where it's now. And when you go to standards like S1000D, it saves you a lot of headaches knowing where the text was initially and where it belonged. And what we do, we actually split the table, so when you link to it, we actually go to the table and we highlight the table header. So if let's say this was not highlighted, we'll know, okay, something is wrong. It was tagged as a table body instead of a table header. And again, you can also add automation by software and write a tool that says, okay, if I'm linking to a table, make sure that it goes really to a table. Or let's say if the keyword figure suddenly goes to a table, and so on. And the reason why we keep labels is that if it says go to table 1-5 and suddenly you link to it and it's 1-7, all of that can easily be checked by automation, and minimizing the amount of time that somebody has to manually go and click on each one of them. If the project is small enough, fine, but if you're dealing with thousands and thousands of references, you're not going to have somebody clicks and make sure that everything is okay. That can be done by automation. And again, this is just an example of how you emphasize specific issues. So in an IQB table, you can actually highlight the figure index versus the figure number, any kind of names are done as a different purple. It's just an easy way for somebody that doesn't have to be, or she doesn't have to be experts in that standard. They can easily review the data and see if there's any issues. Okay. So I don't know if there's any questions.
Well, thank you, Nave. Very informative webinar indeed. The first question has came in around slide 15, and the person wanted to know, what were you using to analyze close and exact matches in the text?
Can you repeat that question?
Sure. The question came in around slide 15, and the question
Okay.
was, what were you using to analyze close and exact matches in text?
Okay. So, I mean, I don't know if I assume we're talking about that slide, but I mean, there's really two cases of it. Number one is when we do the proofreading, and again, so I'm really going to answer it in two avenues because I don't know exactly if they meant when we're proofreading, when we're extracting the data, or when we do the content reuse analysis. But if we're talking specifically about proofreading, you know, if the data comes in as paper, there's really no main source data. I mean, the text is not searchable. If the text comes in as electronically, whether it's PDF normal or Word, we actually do develop a tool that we developed that does a diff between the extracted data and the source data. There's a lot of false negative and a lot of extra errors that we're finding, but that's kind of a raw tool that makes sure that the text was transferred. And we obviously do the review of the data, and we also run QC to look for suspicious characters, whether it's a word that has a digit in between them, a string of letters that suddenly has spaces in between them. So that's what we do with the proofreading. When it comes with the content we use, it's just a tool that we developed that really goes through the entire document set, picks specific base paragraphs, and takes those base paragraphs and runs through the entire document to some sort of algorithm and takes those base paragraphs and looks for those base paragraphs throughout your documents and finds exact matches, number one, and number two, finds any kind of paragraphs that are somewhat similar to some extent. So obviously, we limit it to the amount of words that are similar, but if there are 4 or 5 words that are different, we still flag it as a similar text. So it's really both tools and processes that we developed. It's not off-the-shelf tool that we're using.
Thank you, Nave. So a follow-up question would be, is this tool proprietary?
Well, again, proprietary is a problematic word, especially when you go to government. It's something that we developed. It's not. It has some algorithm in them, but it's really at this point it's really just a push of a button. So it is something that we either are running, and we run it regardless of whether the client wants it or not. We run it for our purposes, for our QA purposes, and for our, depending on the standard that we're going to, but for our planning purposes. But it is something that we developed, but something that can be licensed, and it can be something that can be run on any kind of data as many times as you want, and that's basically it.
Great. Thank you, Nave. The next question has come in is, who is responsible to make sure QA was implemented?
So again, it's a tough one. It depends on the size of the project, also the organization. You know, some organizations are really big enough to have really somebody specifically assigned for that, if it's a QA manager or best practices implementer or an auditor. I mean, I don't know. So it's not really shown over here, but really the way to do your project is better to split it into steps. And what we specifically do is have number one, the team that is working on the data responsible for running the QC tools, for implementing the rules, for checking it. Now, at the same time, the project manager is really the one that owns the project, and he's the one responsible for and accountable for the project. But every step of the process, when you get into production, so let's say you have the OCR, then you have the proofreading, the styling, the preparing of the file, the conversion, the parse and view, and so on. That team is responsible for that QA step.
Great. Thank you, Nave. The next question has come in is, how do you check element accuracy?
So, I mean, element accuracy is actually that tools out there, like like Schematron, and or you can that you can kind of customize for your rules. You can actually if you don't want to go to and get off-the-shelf tool, you can actually develop. You can develop a schema, and that's really the easiest way, and limit the value that is used into the element. Now, how do you determine if let's say, a reference went to a figure and you should go to a table? That's really, it's not as specific in your process where you see. It's really in every step you do those checks. So let's say if you OCR, you make sure that a figure was OCR'd as a figure. And if a table is done properly, it's done properly. And again, the reason why we find somewhat a DMRL-like tool, we extract the high-level titles into a spreadsheet, and really a lot of time map it over there for two reasons. Number one, you track and you know how your data is going to be tagged even before it's tagged. Before you jump into conversion and convert everything, actually everything is centralized into a spreadsheet where at least you know the top element. So standards like beta S1000D, which is the DMRL, but 40,061, which is the work packages, you can actually, even by automation, map the data over there, the element, and then you can have either a subject matter expert or a technical writer, and again, depending on what the data is, if it's a troubleshooting flowchart, you do need a subject matter expert or a technical writer to write it maybe. But we really find that process very effective. So really, we do the mapping over there, and then we have a QC software that you can write in any kind of format, whether it's a schema, a customized schema, or Perl script or C++ script that goes through the document and makes sure that, let's say, a part number is not just a very long paragraph, or if you have a TO number, actually it's just one word, or a step is something like 1 or 2 words. So, it's done both by automation, both by viewing, and both by mapping the high-level elements at the beginning of the process.
Great. Thank you, Nave. The last question that's come in is, how do you QA cross-references?
Okay, so that's a lot of people, if the project is small enough, they really have somebody clicking on every reference and making sure that it's going the right way. But that's when you start dealing with a big project, it's really impossible. And what we do, and again, the reason why we maintain the original label, paragraph label, page numbering, and so on, all the way until almost the last step, is because it's easier to track. So if you click on something that says figure 1-5, and you see that this is figure 1-5, it's done, and that can be done by automation. The cross-reference has, when you convert your data, you have to do it by automation, because software cannot think. But if you have a set of rules that are predefined, it's guaranteed that the software is going to do the most accurate mapping. And then once you do the tagging, and let's say in actually, I think in the conversion specification, for example, over here, when you predefine cross-references, so let's say your predetermined rule is that every time you see paragraph number or par or section, you have to predefine those set of rules up front. Those automation has to be done by automation. You obviously need to do some cleanup after the fact. If, let's say, figure 1-5 doesn't exist over there, or you have a very complicated pattern, like, let's say, see figure 5 in the next chapter. So it could be that software will link to figure 5 in this section and not in the other part. So there's always a combination of manual and automated process. But the linking really has to be done by automation, which is going to be a lot more consistent and a lot more accurate.
Great. Thank you, Nave, and thank you, everyone, for attending. This will conclude today's broadcast. You will be able to access the recorded version of this webinar from the webinar archive section of our website located at www.dclab.com. Again, thank you, everyone, and have a great day.